So in this video, I will be discussing your science pre-board question paper. The first question given to you was, the image below shows a reaction between zinc and hydrogen, and then they have given us a reaction involving zinc and hydrogen. Which option shows oxidation? So they are talking about oxidation now. So let us recall the definition of oxidation. Oxidation is gain of oxygen or it is loss of hydrogen. But we had also learned an acronym oil rig, right? So oil means oxidation. Oxidation is loss of electrons. Reduction is gain of electrons, right? So oxidation will mean losing electrons, that is losing negativity, and reduction is gaining negativity. So when we lose negativity, we get oxidized. When we lose positivity, we get reduced. When we gain negativity, we get reduced. When we gain positivity, we get oxidized, right? So let us look at what changes are happening. So if we gain positivity, it means we are getting oxidized. So when we look at option A, Zn is being converted to Zn plus 2. So neutral Zn is gaining positivity, right? Zn is gaining positivity. So this means this is oxidation. 2 H plus ions, this positivity is being lost. H plus ions are getting converted to neutral H2 molecules. So they are losing positivity. So this must be reduction. So this cannot be our answer. Option C, again, positivity is being lost. Initially, it had positive charge. After the reaction, it is losing its charge. So this again is reduction. The fourth one, H2 getting converted to 2 H plus ions. So here also there is gain of positivity. That means it is oxidation. So we have two reactions in which we have oxidation. So which option shows oxidation? We have two things. Now we'll have to compare which one of these changes is taking place in the reaction given to us. Is Zn gaining positivity to become Zn plus 2? Yes, Zn is getting converted to Zn plus 2. But do we have hydrogen gas gaining positivity to become H plus ions? No, we have hydrogen gas on the product side. Hydrogen gas is not turning into H plus ions. H plus ions are getting converted to H2, right? So this option, option D, is not pertaining to the given reaction, is not right according to the given reaction. This change is not taking place within the reaction. So we are left out with just one reaction, one change, Zn to Zn plus 2, which is both oxidation and this change is taking place in the given reaction. So our answer is option A. So first question, the answer would have been option A. Okay, moving on to the second question. A visually challenged student has to perform a lab test to detect the presence of acid in a given solution. The acid base indicator preferred by him will be blue litmus, clove oil, red cabbage extract, or hibiscus extract. So here the keyword is visually challenged person is trying to detect acid base indicator. So visually challenged and indicator, that means we cannot use the indicator which changes color. We'll have to use olfactory indicators. And we have three olfactory indicators mentioned in our textbook: onion, clove oil, and the last one is I think vanilla extract. So out of these three choices, we'll have to choose the option given to us. Blue litmus, it changes color, so we cannot use this. Red cabbage extract changes color, hibiscus extract changes color. So the only olfactory indicator given to us is clove oil. So option B is the right answer. So question 2, option B is the right answer. Next, third question. The solution in the given figure is likely to be dash. So we'll have to choose an option. So let us look at the figure. They have given a battery. They are showing us two electrodes being dipped into a solution of some kind. And they're asking us what kind of solution is it. And they have written, mentioned within the figure that the bulb does not glow. So if the bulb does not glow, that means the solution must be poor conductor of electricity. Poor conductor of electric current. So poor conductor of electricity, again will go to ionic compounds and covalent compounds. So solutions of ionic compounds will be good conductors. Covalent compounds will be bad conductors or poor conductors. So they are asking us indirectly to recognize or to identify which one of these is covalent. Because the bulb is not glowing, we are concerned about choosing covalent compound. So HNO3 is acid. Acid releases H plus ions, so ions are being formed, so this must be ionic, so this is not the answer. H2SO4 is again an acid. Acids dissociate in water to form H plus ions, so this again won't be the covalent compound. Carbon dioxide in water. Carbon dioxide is covalent compound, but when it is dissolved in water, carbon dioxide dissolved in water forms carbonic acid. Carbonic acid, which is used in cold drinks, right? So carbonated water is used in Coke or Thumbs Up, all the cold drinks which we drink. So carbonated water will contain carbonic acid, and because it contains acid, it will dissociate to release H plus. So that means although carbon dioxide is covalent compound, carbon dioxide in water will be forming acid. That is why this again will be a good conductor of electricity. But we know C2H5OH. C2H5OH is nothing but ethane all, right? OH means it is alcohol. And we know that alcohol is a poor conductor of electricity. It doesn't dissolve in water. It doesn't dissociate in water. So our option is option B, ethanol. Ethanol won't be conducting electricity through its solution. So correct option for question 3 will be option B, C2H5OH. And in order to confuse you, they had given option D, CO2. Okay, moving on. Question number 4. A student added acetic acid to test tubes 1, 2, 3 and 4 containing the labeled substances and then brought a burning splinter near the mouth of each test tube. So he's bringing some burning splinter. Don't concentrate on the word splinter. Splinter just means any small wooden substance or a wooden stick. So just imagine a person is using a matchstick, a lit matchstick. A burning matchstick is being brought near the mouth of each test tube. The splinter would get extinguished. The keyword is it was burning and now it has gotten extinguished. Which gas is used in extinguishers? We know that CO2 gas is used in extinguishers, right? So CO2 gas is extinguishing the burning splinter. So that means the test tube in which this extinguishing of flame is taking place must be releasing carbon dioxide gas. So which chemical are they using? They are using acetic acid. We know acetic acid is ethanoic acid. So acetic acid is ethanoic acid. And this ethanoic acid should react with something to produce or release carbon dioxide gas. We know only one such reaction in which ethanoic acid releases carbon dioxide. That is because it is an acid. Ethanoic acid can react with base or metal carbonates, right? Metal carbonates and metal hydrogen carbonate. Because we need carbon dioxide gas to be released, it will be reacting with metal carbonates or metal hydrogen carbonates. So we'll just try to identify the option which has either carbonates or metal hydrogen carbonates. So first option, NaOH, is metal hydroxide, not metal carbonate. So this is not the correct answer. NaCl is metallic salt, metallic chloride, not carbonate. Option 3 has metal hydrogen carbonate. So this is the right test tube where extinguishing of burning splinter will take place. Test tube 4, they are using metal hydroxide. So this again is not carbonate or metal hydrogen carbonate. So this also won't be the answer. So option C, test tube 3 is the answer. Fourth question, choice C. Question number 5. Vinegar is a solution of dash. This is a textual or a factual question. So option C, 5 to 8% acetic acid or ethanoic acid in water. This solution is known as vinegar. So fifth one, option C. This was asked from the properties of ethanoic acid, the physical properties. Next question, question number 6. You might have faced problem. Most of you might have faced problem in solving this question. So let us just break out this question into parts. Sodium chloride is reacting with a substance A to form hydrogen chloride. Let us write it down. Sodium chloride is NaCl. NaCl is reacting with some substance A to form HCl. So NaCl plus A is forming HCl plus something else might be being formed. Next, HCl in turn is reacting with some substance B to form iron chloride. Iron, they have given it to be iron 2 chloride. So Fe has the charge of +2. So Fe +2 and chloride Cl -2. So it will be FeCl2 plus something else might be formed. Next, the same hydrogen chloride is reacting with C to form ammonium chloride. NH4 ammonium ion, NH4 positive charge, chloride negative charge. So it will get cancelled out. So NH4Cl plus something else must be formed. And lastly, they have given us HCl reacting with D to form lead chloride. So HCl reacting with D to form lead chloride. Lead is Pb +2, chloride is Cl -1. So PbCl2 will be formed along with some other substance. There might be many products being formed. We don't know whether a single or multiple products are being formed. So let us look at the options given to us. The first option here given to us is, when we compare, we have just two choices for A. It might either be HCl or it might be H2SO4. So if I write HCl or H2SO4 here, so we can see we already have chloride with sodium, and if we use an acid containing chloride, what reaction might take place? Sodium might displace hydrogen and hydrogen will displace sodium. Then what will be formed? Again HCl and NaCl will be formed, right? So we cannot use this because both the salt and the acid containing chloride and chloride won't be useful. So we will have to choose the acid which doesn't contain chloride, because the salt already contains chloride. We'll have to choose the other choice. So A must be H2SO4. We have chosen H2SO4 because sodium chloride already has chloride. So if we use an acid which also contains chloride, no reaction will take place basically. So we have identified A to be H2SO4. So let us cross out all the options which contain HCl. A cannot be HCl because salt NaCl already contains Cl. So we are left out with two options, B and C. So now we'll compare B and C. A is the same, considered H2SO4, considered H2SO4. B is again the same, Fe and Fe. D is again the same. So we are just concerned about the reaction involving C. So we'll be looking at just this reaction, HCl reacting with C to form ammonium chloride. So let us look at that. HCl reacting with C to form ammonium chloride, NH4Cl. Let me write two reactions, C to form NH4Cl. Now, when I look at the options given to me, C can either be ammonium hydroxide, NH4OH, or it might be ammonia gas. So let me replace C with ammonium hydroxide, NH4OH, and ammonia gas, NH3. Now we see HCl is an acid. NH4OH is a base. It is a strong acid. It is a weak base. So strong acid will react with weak base to form acidic salt, right? Or they have given us HCl, which is an acid reacting with a gas to form a salt. So out of these two reactions, which one is most likely to take place? Because a salt is being formed, salt is always formed by neutralization reaction between an acid and a base. So C must be ammonium hydroxide. So we'll choose the option containing ammonium hydroxide, option B. Although NH3 when it combines with, say, plus HCl, so 3 plus 1 will become NH4 and Cl. Although this is being formed, we'll prefer the one which involves neutralization reaction. So we'll choose option B as the answer. Question 6, option B. Although both answers should have been correct, because both the reactions will take place. So the answer might have been B and C, but we will be favoring option B because salts are created. A salt is being created, and salts are created only by neutralization reaction, usually by neutralization reaction. Okay, moving on. Seventh question. In the decomposition of lead 2 nitrate, so let us write down its molecular formula. Lead has the symbol of Pb. They have already given us the valency of 2, so +2. And nitrate, we should know its molecular formula NO3. And we should know its valency. Its valency is -1. So when we cross it, we get PbNO3 twice. So this in decomposition of lead nitrate to give lead oxide. Acha. So this was an activity in which we heated lead nitrate and we got brown fuming gas, nitrogen dioxide gas, and lead oxide is being formed. So this decomposition is forming lead 2 oxide. So lead is Pb, 2 means plus 2. Oxide, we know it has valency of -2. So PbO is being formed. Plus nitrogen dioxide. So NO2. Carbon dioxide is CO2. Nitrogen dioxide will be NO2. Plus and oxygen gas. They're talking about oxygen gas. So O2. Most gases are diatomic. Don't just write it to be O or O3. O3 will be ozone. O will be atom of O. O2 will be the molecule of oxygen gas, and O3 will be ozone. Now they are asking us to balance this equation. So after writing the molecular formula and forming the skeletal equation, now we can move to balancing the chemical equation. So let us look at Pb. Pb is already balanced. What about nitrogen? Nitrogen, we have 2 nitrogens. So we might have to use 2 here. Let us look at oxygens for now. Oxygens, we have 3 to the 6 oxygens. So oxygen has an even number. So whatever coefficient we add, here if we add 2, 3, 4, 5, any coefficient being added on the reactant side, we'll always keep oxygen to be even, right? When we look at the product side, we have this to be even. The third product is even, the second product is even, but the first product is not even. It doesn't have even number of oxygens. So we will have to make it into an even number. To make the first product as even, we'll have to add a even coefficient. So we added 2 to PbO. So the balancing coefficient of PbO will be 2. Now because Pb became 2, we'll have to add the coefficient of 2 on the reactant side as well. So now when we look at nitrogens, how many nitrogens did we have initially? 1 2za. 1 2za was 2. 2 2za will be 4. So we'll have to add 4 to nitrogen on the product side. Now when we count all the oxygens in the first product is 2. Oxygen in the second product is 4 2za 8 plus 2. And on the reactant side we have 3 2za 6. So 6 2za 12. So we need 12. We have 8 plus 2 10, 10 plus 2 12. Achha, it is balanced now. So this is the balanced chemical equation. 2 Pb NO3 twice being decomposed to form 2 PbO plus 4 NO2 plus O2. What have they asked us? The coefficient of nitrogen dioxide. So the coefficient of nitrogen dioxide is 4. So option D will be the answer for 7th question. 7th question, option D, 4 is the right answer. 13th question, a student determines the focal length of a device X by focusing the image of a far off object on a screen positioned as shown in the figure. The device X is dash. So they have not given us a figure basically. So the figure, when we read the question, a student determines the focal length of a device X. So the device might be concave lens, convex mirror, convex lens, convex mirror, and concave mirror. Okay. Now, because they have used the word screen, that means real image is being formed. Can convex lens form real images? Yes, it can form real. Can concave lens form real images? Concave lens always forms virtual images. So this cannot be our answer. Convex mirror also forms virtual images. Concave mirror can form both real and virtual. So we have eliminated 2 options. It can either be, the correct option can either be A or D now. So what is the difference between convex lens and concave mirror? They are keeping the object, it is a far off object. That means object is at infinity. We consider the object to be at infinity. So when we look at convex lens and concave mirror, what is the difference between concave lens and convex lens and concave mirror? When light from infinity falls on convex lens, it gets focused behind the lens. So the screen will be placed after the lens. So we have object first, then we have the device, then we have the screen. But in the case of concave mirror, we'll have parallel rays from object at infinity getting reflected and passing through the focal point, right? So screen will have to be placed at this point. So when we look at the order of placement, we will have the object first, then we'll have the screen, and then we'll have the device. So basically the figure which should have been given to us would have either object, device, then the screen in this order, or it might have been object, screen, and device. So based on the figure, we would have answered this question. So this question, I think it is wrong. They have corrected it as a type of reflecting object like mirror or a lens. Because they have used the word reflecting, we'll have to choose concave mirror itself because it is reflecting. Lenses do not reflect light, lenses refract or bend the light. So in this case, we'll have to choose option D, but the question itself is wrong because they have not given us the figure. Next question 14. A person went for a medical checkup and found that the curvature of his eye lens was increasing. So let me draw two lenses, a thin lens and a thick lens, crystalline lens. So its curvature, the one with the thin lens has less curvature, and the one which is thicker will have more curvature. It is more curved, right? And we know that thinner lenses will have a longer focal length, thicker lenses will have a shorter focal length. They are talking about curvature of his eye lens was increasing. Curvature increased. So increased curvature means the lens is becoming thick. It is becoming more curved. So if the lens becomes more thick, then the focal length will become more small or shorter. So focal length is becoming shorter means short-sightedness. Short-sightedness will have a short name, which is myopia. Myopia is short-sightedness. One of the causes for short-sightedness is increased curvature of eye lens. We are not talking about radius of curvature, we are talking about the curvature itself. Curvature is the curved part of the lens. If it is less curved, then it has less curvature. If it has a greater curve, then it has more curvature. So less curvature lens will be thinner lens, more curvature lens will be a thicker lens. So the option answer to this question will be option A, myopia, short-sightedness. Next question, question 15. Two bulbs have the following ratings. So they have given us a rating here. The ratio of their resistance, and they are asking us resistance, not just resistance, they are asking us the ratio of resistance. So let us consider, find out what have they given us. They have given us watts and volts. Watt is the unit for power, so they have given us power, and volt is the unit for voltage or potential difference. Potential difference is denoted by V. So they have given us power P, they have given us voltage V, and they are talking about resistance R. So the formula which combines all these is power is equal to V square upon R, right? And because we need to find resistance, resistance should be our answer. So we'll be interchanging these two terms. We'll be transposing these two terms. So resistance will have the formula of V square by P. And because we need the ratio of these two resistances, let us call the first resistance to be R1. So they are basically asking us to calculate R1 by R2. So R1 by R2 will be, because R has the formula of P square by V square by P. So let me write down V1 square by P1 will have to be divided by V2 squared by P2. Let us just substitute the values in this. V1 is 220. So 220 square, 220 into 220 divided by P1. P1 is 40. So 40 divided by can be converted into multiplication. We'll have to reciprocate the second fraction. So P2 will come to the numerator. P2 is 20. So 20 in the numerator with V2 square in the denominator. V2 is 110. So 110 square in the denominator. So when we try to simplify these, we can cancel out all the zeros. We have 3 zeros in the numerator, 3 zeros in the denominator. So those can be cancelled out. Next, we can see 11 ones, 11 twice will be 22. 11 ones, 11 twice will be 22. So we basically have 2 into 2 into 2 divided by 4. So this 4, 2 to the 4 will get cancelled out. So we are left out with just 2. So the fraction is nothing but 2 by 1. So R1 by R2 is 2 by 1. That is R1 is to R2 should be 2 is to 1. So the answer is 2 is to 1. We don't need to multiply everything and then keep simplifying. We can just cancel the terms out. To make things easier, they have given us values such that it will be easier to calculate. So answer of question 15 is option A, 2 is to 1. Option A, 2 is to 1 is the right answer. Next question, question 16. A student places some iron filings around a magnet. The iron filings arrange themselves as shown in the image. Done. The student labeled 4 different regions around the magnet. Okay, he has labeled them as P, Q, R and S. Where would the magnetic field be the strongest? So in a bar magnet, we know that magnetic field is the strongest at the poles, North Pole or the South Pole. But they have not mentioned which pole is north, which pole is south. It's okay, but we need the region around the pole of the magnets. The region around the pole of the magnets is very strong. Magnetic field at within those areas are very strong. So is this region nearer to the pole, or is this region nearer to the pole? Is this, let me change the color, this region, this region, this region, or this region? So because R is nearer to the pole, so R must be our answer. So for question number 16, option C is the right answer. Just remember, for a bar magnet or any magnet for that matter, magnetic field will be strongest at the poles or nearer to the poles. Next, 17th question, assertion and reason. Assertion: ethanol turns blue litmus red. Ethanol turns blue litmus red. We know the difference between ethanol and ethanoic acid. Ethanol has OH, and ethanoic acid, it's the name itself indicates it is an acid. So ethanoic acid is acid, so it will turn blue litmus to red. But what about ethanol? Ethanol contains OH, so it must be basic in nature. So it will be converting red litmus to blue. The statement given to us is ethanol turns blue litmus red. Blue litmus to red is ethanoic acid, not ethanol. So this statement is false. So if this statement is false, assertion is false, it must be option D. So 17th one, option D must be the answer. Next, 20th assertion: a current carrying conductor or a wire deflects a magnetic needle placed near it. Is it true? Yes, it is true. Due to magnetic effect of electric current, a magnetic field gets generated. Whenever current passes through a conductor, there are magnetic fields, concentric magnetic field lines being generated right around the conductor. So when we place a magnetic compass, when we bring a magnetic compass nearer to this current carrying conductor, its needle will get displaced or deflected. So this statement is true. Next, reason: a magnetic field exists around a current carrying wire. Yes, this is also true. There is a magnetic field around a current carrying wire, and it is getting deflected because of this magnetic field, interaction of magnetic field of the wire and the magnetic field of the magnetic needle of the compass itself. So due to the interaction between two magnetic fields, there is deflection taking place. So both the statements are true, and it is the correct explanation. A current carrying wire deflects a magnetic needle placed near it because a magnetic field exists around a current carrying wire. So this statement makes sense. So question 20, option A would be the right answer. Next, question 21. So question 21, what happens to ZnCO3 when it is heated without oxygen? ZnCO3, zinc carbonate. This is from the chapter of metals and non-metals, zinc carbonate. The next question is copper oxide and copper sulfide. So even if you were not able to recognize the question being from the chapter of metals and non-metals, now after looking at all these three chemicals, carbonate, oxide and sulfide, we have three kinds of ores, right? Ores can be oxides, sulfides and carbonates. To make things easier, I told you C for carbonates. Carbonates will use calcination. Sulfides, S. In the alphabetical order, we have R and S together. So roasting will be used for sulfides. And we know that roasting is done in an open vessel or an open container. So it will have excess supply of oxygen. Whereas calcination will be not having oxygen being supplied. So it will have lack of oxygen or limited amount of oxygen. and oxides can be converted by making them reduced or by reducing them with reducing agents like coke or just pure form of carbon. So by looking at these three things and by analyzing all these things, we'll have to use roasting or calcination and or reduction by using coke. Let us now try to tackle these questions. What happens when zinc carbonate is heated without oxygen? Zinc carbonate, so ZnCO3, because it is carbonate, it will have to be extracted by using calcination. Calcination will be without oxygen. So they're asking us what reaction takes place when zinc carbonate is heated without oxygen. So we'll write zinc carbonate will be subjected to calcination, in which we heat zinc carbonate without oxygen, without the supply of oxygen. And during calcination, zinc carbonate will undergo thermal decomposition to form zinc oxide and liberate carbon dioxide gas. So carbon dioxide gas will be released. So this is the reaction which is taking place. We'll have to explain it and we'll have to write a balanced chemical equation along with the states. Zinc carbonate, because it is a ore, it will be solid. Zinc oxide, again ore, solid. Carbon dioxide, gas. Next, question B. A mixture of Cu2O and Cu2S is heated. So instead of heating them individually, they are mixing them and heating it. So we know Cu2O plus Cu2S, when it is heated, it will be used for extraction of copper itself, right? Our main goal is extraction of copper, and during the extraction of copper or any ore for that matter, sulfides will get converted to oxides through roasting. Carbonates will get converted to oxides by roasting. Oxides are themselves in oxide state, right? And they have given us zinc oxide, a mixture of zinc oxide and zinc sulfide is being used. So, and lastly we have oxides. All the oxides will be converted into metals, right? This is the last step. We should get metals at last. So because they are using copper oxide, that means they are trying to reduce copper oxide. So copper oxide should now get converted into pure copper. So we'll write copper for now. So if we take out copper out of the two reactants, if we remove copper and copper, we'll be left out with S and O. That is, which gas will be formed? Sulfur dioxide will be formed. Here we had carbon dioxide. This time around we'll have to add sulfur dioxide. So sulfur dioxide will get liberated. Let us add the signs G and the arrow mark. Next, now the balancing part. For the balancing part, we'll look at the number of oxygen in SO2. SO2 has 2 oxygens, so we'll need 2 oxides, but they have given us the chemical formula to be Cu2O. We cannot just add 2 as the subscript. We'll have to add 2 as a coefficient. So when we add 2 as a coefficient, the number of total number of copper turns out to be 2 2s are 4, 4 plus 2. 4 in the first reactant, 2 in the second reactant. So when we add them together, we get 6 coppers. So we'll have to add 6 to balance it out on the product side. So adding the states, copper oxide is a oxide ore, so solid. Copper sulfide, again solid. Copper, again solid. Sulfur dioxide is a gas, so G. So this is the reaction taking place. So we'll have to write it, we'll have to explain it. So we'll write copper oxide is being heated along with copper sulfide, and these two ores will get reduced to generate pure or solid form of copper or elemental copper. Copper oxide and copper sulfide, when heated together, will get reduced to form elemental copper and liberate sulfur dioxide gas. This reaction is used in the extraction of copper from sulfide ore and copper oxide ore. So this is the statement and the reaction which we will have to write. This carries just 2 marks. So 1 mark for the first question, 1 mark for the second question. So they will be basically focusing on the reaction itself, but you are supposed to write an explanation, a small sentence, a short sentence along with the reaction also. Okay, or question. The given reaction involved during extraction of zinc from its ore by roasting zinc ore or by calcination of zinc ore. So roasting zinc ore, we already know zinc ore for roasting will have to use sulfide ore of zinc. So sulfide ore of zinc will be ZnS, and calcination of zinc ore. So for calcination we'll have to use carbonate. So zinc carbonate, ZnCO3 will have to be used. For carbonate ores, we'll be subjecting it to calcination, so no oxygen will be required. So again, this we had already written in the first sub question of this or. So this calcination is similar to this A part. A part of the first question has the same answer as B part of the second question. So ZnO plus CO2 gas, solid and solid. So again calcination is taking place. Zns is a sulfide ore. So to convert sulfide ore, we'll have to use oxygen now. So sulfide when heated in the presence of oxygen and subjected to roasting will be forming Zn plus SO. No, sulfide ores will be converted to oxides first. Sulfide ores get converted to oxides first. So we'll have to add O. ZnO will be formed. ZnO plus SO2. So to balance it out, we have 3 oxygens on the product side to make it even, because we have 2 oxygens on the reactant side. So to make it even, we'll have to add 2 here. So 2 oxygen plus 2 oxygen, it became 4 oxygen. So it can be balanced out now. But when we look at zinc, zinc should be 2. So we add 2 here. If we add 2 here, sulfurs also change. Sulfurs become 2. So to balance that out, we'll have to add 2 to the second product. Lastly, the number of oxygens, 2 ones are 2 plus 2 twos are 4. So totally we have 6 oxygens. So to balance that out, we'll add the coefficient of 3. 3 twos will be 6. So this is the balanced chemical equation. Solid, gas, solid, gas. And we'll have to explain the reactions taking place in brief. Next, 25th question. State the laws of refraction of light. So this is not reflection. Don't get confused with reflection. This is refraction. So laws of refraction of light. The first will be the same. The incident ray, the refracted ray, and the normal at the point of incidence. All lie in the same plane. Second law of refraction is Snell's law, which states the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. And this constant for a given pair of media, for a given pair of media. And this constant is known as the refractive index. Refractive index of the media. Okay, so we have stated the 2 laws of refraction. Next question, part B, is if the speed of light in vacuum is this, find the absolute refractive index of a medium. So they're asking us absolute Ri. So for absolute Ri, we know the formula to be N of medium to be equal to C by V. So where C is the velocity of light in vacuum, and they have given us the value 3 into 10 raised to 8 meters per second divided by speed in the medium is 1.4 into 10 raised to 8. 1.4 into 10 raised to 8. So basically these two things will get cancelled out. So 3 divided by 1.4. So we'll multiply this by 10, this by 10. We will be getting 30 by 14. 2 7s are 2 15s. So 15 by 7. So when we divide 15 by 7, 15.000 divided by 7, 7 2s, 14, 7 1s, 7, 7 3s are 27, 4s are 28. So basically 2, 7 2s are 14. So this will be equal to 2.142 or 2.14. So N of M is approximately equal to 2.14. This will be our answer for sub question B. Next sub question A. Define power of a lens. Power of the lens is the ability of the lens to bend the parallel beam of light. What is its unit? Its unit is diopter, denoted by capital D. So when you write diopter as a word, use small d. But when you write its symbol, it will be capital D. Next is a numerical based question. Subpart B. One student uses a lens of focal length 50 centimeter and another of focal length minus 50 centimeter. What is the nature of the lens? So for nature of the lens, we'll have to write its name, the type of the lens, and its nature, whether it is converging or diverging. So we'll have to write both. So focal length is 50 centimeter. So there are 2 students. One student A uses focal length of plus 50 centimeter. Student B uses focal length of minus 50 centimeter. So because focal length is positive, that means the lens is concave, convex lens. Convex lens has positive focal length. Concave lens has negative focal length. Lastly, we need its nature. So nature of convex lens is converging. It is a converging lens. Nature of the lens in the second case for student B will be diverging lens. So we have written the name and the nature of the lens. Lastly, they have used us to asked us to calculate power used by each one of them. So for power, we have the formula of P is equal to 1 by F, but this formula is when F is in meters, but it will be 100 by F when F is in centimeters, right? So for the first case, power will be equal to 100 divided by positive 50, which will be 50 once, 50 twice. So power will be plus 2 diopter D. And in the second case, P will be equal to, because it is again 100 by F in centimeters, so it will be 100 upon minus 50. So this time around we'll get positive divided by negative will be negative. So 2, 5 2s 10. So minus 2D in the second case. So we have written the nature of the lenses and the powers of the lenses used by two students. One student uses a lens of this and another student uses a lens of this. What is the power used by each of them? Power of each lens. Question number 27. Compound X and aluminium are used to join railway tracks. This is one of their favorite reactions. Join railway tracks, weld heavy machinery. We use Thermit reaction, right? So Thermit reaction, name the reaction. Reaction is Thermit reaction. But along with this, you also write down its type, Thermit reaction, or it is a exothermic, highly exothermic displacement reaction. Displacement reaction. So we do not know whether they are trying to ask us the technical name of the reaction or the type of the reaction, name of the type of reaction. So we'll have to write down both of these in order to be sure. Identify the compound X. So X is heated with aluminium, and we know that railway tracks are made up of iron, so Fe. So we'll have to use iron oxide or Fe2O3. So we'll write down X. The metal X or the compound X is Fe2O3, which is iron oxide, or because its valence is +3, right? So it is ferric oxide. So we'll write both the scientific name, the common name, and its molecular formula. Next, B we have already answered. B part, it will be either thermit reaction or highly exothermic displacement reaction, and we will have to write down its equation now. Write down its reaction. So reaction is between Fe2O3 with powdered aluminium. So powdered rust, iron oxide with aluminium to form displacement reaction will take place because aluminium is more reactive than iron. Aluminium Al2O3 will be formed along with Fe. This Fe will be in liquid form. Al2O3 will be in solid form. It will float over this liquid. This is solid and this is also a solid being formed. So this is a reaction along with too much heat. The heat is so high that this iron itself melts. The iron being formed is in molten form. Question 28. Write a balanced chemical equation for each of the following reactions. Lead acetate solution is treated with dilute hydrochloric acid to form lead chloride and acetic acid solution. So you might face some problems in this reaction because it involves lead acetate, and you do not we have never used less lead acetate anywhere. So okay, still we might try to tackle it. Let us just try to tackle this reaction for now. So lead, let me just write down lead acetate. So this is reacting with dilute hydrochloric acid. We do not know the formula of lead acetate for now, but we know the formula of hydrochloric acid, right? So HCl could have been written to form lead chloride. We do not know the valency of lead, so but we know the symbol of lead. Lead is Pb and chloride is Cl. We know chlorine is halogen gas, so its valency will be -1. And if in case you do not know the valency of Pb, they had given you Pb's valency somewhere before. So if we come back to that question, so that question was This question number 7. In decomposition reaction, lead 2 nitrate. They have given us the valency of lead to be +2. So we'll be using that now. So lead has the valency of +2. So I will write +2 as the valency. So its molecular formula of lead chloride will be PbCl2, right? Plus, lastly, the last product is acetic acid. Acetic acid, we know it is ethanoic acid. Ethanoic acid will have the formula of CH3COOH, right? So this itself is acetic acid. So from this, if we need lead acetate now, so to form lead acetate, what kind of reaction will take place here? This must be some salt, and this salt is reacting with acid to form a different metallic salt and forming a different acid, right? Acetic acid is being formed. So because salt and acid are reacting to form a solution of another salt and acid, that means what kind of reaction is taking place? Displacement reaction must be taking place. So whenever acid undergoes displacement reaction, hydrogen will be displaced out, right? So in lead acetate, we will have Pb, right? In order to form PbCl, this Pb is displacing hydrogen out of the solution of HCl. So Pb is displacing hydrogen out to form PbCl. And what else is being formed? This hydrogen is combining with some part of this molecule, that is the acetate part of this molecule, right? Hydrogen will combine with acetate to form CH3COOH, right? So that means this H in the acetic acid, this H has been obtained from this HCl. So when we break PbCl2 in two parts, we get Pb. Pb was from this CH3COOH will have to be broken down into two parts. So this H is from HCl. This Cl is again from HCl. So this CH3COO should be from the first reactant, right? So this is from first reactant. This is from second reactant. This should be from first reactant. This will be from the second reactant, right? So from using this, by using this logic, we can now form the molecular formula for lead acetate. Lead acetate will be Pb with the valency of +2 and CH3COO, right? CH3COO, because hydrogen has valency of +1, COO will have the valency of -1. We have already seen this in soap also, CH3COO negative and Na positive. This COO part has a valency of -1. So this is -1. So in order to form the molecular formula of lead acetate, we'll have to add 2 as a subscript. So lead acetate will have this molecular formula. We can write it as PbCH3CO twice plus HCl to form PbCl2 plus CH3COOH. Now, how many acetates do we have? We have 2 acetates, right? So we'll have to add 2 as a coefficient of acetic acid. So if we add 2 as a coefficient of acetic acid, that means we are adding the coefficient to hydrogen also, and this hydrogen was obtained from HCl. So we'll have to add 2 here. Or we can look at chlorine. Chlorine, we need 2. So we'll have to add 2. So now the whole equation has been balanced out. So the balanced chemical equation will be PbCH3COO twice plus 2HCl. This will be in liquid form or aqueous form, aqueous solution. These two will react to form PbCl2 because it is chloride. It should be aqueous plus CH3 2CH3COOH, which is in aqueous form. So this is the chemical reaction for the first one. The second sub question: a piece of sodium metal is added to absolute ethanol to form sodium ethoxide and hydrogen gas. So this we already know, reaction of sodium metal with ethanol to form sodium ethoxide and hydrogen gas. We already know this reaction. Sodium metal Na reacting with absolute ethanol or just ethanol. Ethanol's molecular formula will be CH3, CH2 and OH to form sodium ethoxide and H2 gas, liberate hydrogen gas. So hydrogen gas will be liberated when sodium displaces hydrogen, right? So if sodium displaces hydrogen, what will be formed? CH3, CH2 and O Na plus, this molecule will be formed. This molecule itself is known as sodium eth oxide. Sodium eth oxide. It has a sodium part, it has ethane part, eth, and it has oxide part, sodium ethoxide, plus hydrogen gas. To form hydrogen gas, we need two atoms of hydrogen to be displaced, right? So to displace two hydrogens, we'll need two ethanol molecules. So if we have two ethanol molecules, two sodium ethoxides will be formed. If we need two sodium ethoxides, that means sodiums must also be 2. So this is the balanced chemical equation for the second equation, for the second reaction given to us. So sodium will be solid, this ethanol will be aqueous or liquid. Next, this will be again aqueous because it is soluble in water. This is a gas being formed. Next, the last sub question, iron 3 oxide. They have also given us the valency of iron. Iron has a valency of 3. Iron 3 oxide on heating with carbon monoxide gas react to form solid iron and liberates carbon dioxide gas. So they are basically reducing, they're using extraction of iron from iron oxide. So solid iron is being formed by using iron oxide. So its chemical reaction will be iron 3 oxide, right? So iron has valency of +3 and oxide. So oxide will have the valency of -2. So Fe2O3 is reacting with sodium carbon monoxide. They've used the word carbon monoxide. So CO to form solid iron. So solid iron will be Fe plus which gas is being released? Carbon dioxide gas is being released, CO2. So we'll write CO2. In order to balance this out, how many oxygens do we have on either side? 3 plus 1, which is 4. So even number, and here also we can form even number. Okay. So to balance this equation out, let us look at the structure of Fe2O3. Fe2O3 has 2 Fe's and 3 oxygens, and carbon monoxide just has 1 carbon and 1 oxygen. On the product side, we have just Fe plus we have carbon dioxide. Carbon dioxide will have 2 oxygens attached to carbon dioxide, right? So now, when we look at carbon monoxide is getting converted to carbon dioxide. To convert carbon monoxide to carbon dioxide, we'll need another oxygen. So where do we get this oxygen from? We'll be getting oxygen from Fe2O3, right? But one carbon monoxide can only combine with one oxygen of Fe2O3. And how many oxygens does Fe2O3 have? It has 3 oxygens, right? So every oxygen will require its own CO molecule, right? To form 3 CO2 molecules. So we'll add 3 CO2 on the product side and 3 COs on the reactant side. Now oxygen has gotten balanced, carbon has gotten balanced. We have 3 carbons, and oxygens we have 3 plus 3, 6, and we have 3 to the 6. So basically carbon and oxygen got balanced out by rearranging, by looking at what change is taking place to convert carbon monoxide into carbon dioxide. Now when we look at iron, we are left out with 2 irons on the reactant side. So there must be 2 irons on the product side. So we'll add the quotient of 2 here. So now the chemical equation is balanced. Fe2O3 is rust, so it will be solid form. Carbon monoxide is a gas, so gas. Iron, solid form. They have already mentioned it within the question itself. To form solid iron, so they have given us the state 2. So it is solid and it releases carbon dioxide gas. They have used the word gas again. So gas, solid, and gas. Most of the states were given. The only state which was not given was for iron oxide. We already know it is rust. Rust will be in the powder form or solid form. Okay, 30th question. In the given circuit, find the total resistance of the network of resistors. So when we look at the given circuit, we'll try to follow the current. So a current is being generated within the circuit. This current, when it reaches this point, it gets divided into 2 branches, right? So this point, at this point, parallel connection starts. And then we have 2 currents, I1 and I2. Let us call the main current to be IT. IT is getting divided into I1 and I2. And the same current, I1, is flowing through both the resistances, 4 ohm and 2 ohm. And I2 is flowing through 3 ohm and 3 ohm. And then these 2 currents are combining again at this point. So this must be the second parallel connection, parallel point at which parallel connection is taking place. So we have seen 4 ohm and 2 ohm are in series, so we can just add them together. So our circuit will turn out to be 4 plus 2, which is 6 ohm. 6 ohm is in parallel with, because again 3 ohm and 3 ohm are in series, we can just add them together. 3 ohm plus 3 ohm will be 6 ohm. So basically our circuit is 6 ohm connected in parallel with 6 ohm to a battery of 6 volt along with an ammeter and a switch. So when we combine these two, what do we get? We already know when we have equal resistances, our answer will always be divided by the number of resistances. So each resistance is of 6 ohm. So Rp will be equal to each resistance R by N. So Rp will be equal to each resistance divided by the number of resistances. So Rp in this case will be 6 upon 2. So 2 ones, 2 threes. So Rp will be 3 ohm. So effective resistance has this value 3 ohm, but we'll have to show it. So we'll we'll draw the diagram and label all the resistances. Let R1 is equal to 4 ohm, let R2 is equal to 2 ohm, let R3 is equal to 3 ohm, and R4 is equal to 3 ohm. So we'll say RS1 is equal to R1 plus R2, which is 4 plus 2 is equal to 6 ohms. Then we'll say RS2 to be equal to R3 plus R4, which is 3 plus 3 ohm, which is again 6 ohm. Now RS1 and RS2 are in parallel. So we'll say 1 by Rp is equal to 1 by R1 plus 1 by R2. In this case, we need total resistance or the effective resistance. So 1 by RT will be equal to 1 by 6 plus 1 by 6, which is 2 upon 6, which is 1 upon 3. So this implies we'll have to reciprocate. So RT will be equal to 3 ohm, which is the final answer which we had got by rough calculation. So this will be the calculation which we will have to show. We'll say R1 and R2 in series. Next, R3 and R4 in series. Finally, RS1 and RS2 in parallel, and we are solving it here. We are showing the solution. Now we know that total circuit resistance is 6 ohm. Total circuit voltage is also given to us as 6. Acha, total circuit resistance is 3 ohms, not 6 ohms. It is 3 ohms. And total voltage is 6 volts. So current through ammeter will be the main current, right? Main current IT. So let us just find out IT value by using Ohm's law. So Ohm's law states V is equal to IR. So VT will be equal to IT RT. VT is 6, IT is unknown, RT is 3. So IT must be equal to 6 upon 3, which is 2 amperes. Therefore, IT is equal to 2 amperes. So this answer is 2 amperes. This answer is 3 ohms. The total resistance is 3 ohms. Now they have also given us OR question. The current flowing through a resistor connected in a circuit and the potential difference developed across its ends are as shown in the diagram by milliammeter and voltmeter readings respectively. The readings of milliammeter and voltmeter respectively. What are the least counts of these meters? Basically, you do not have a least count anywhere within the syllabus. You'll be learning about this in 11th. But as they have asked it to you, let us try to find out what they mean by least count. Least count is nothing but the minimum reading which we can make accurately by using any meter. So in this meter we can see we have 10 divisions between 100 and 200, right? So at this fifth division it will be 150 milliamps, right? So each division between 100 and 150 will represent 10 milliamperes, right? Because we have 5 divisions, 1, 2, 3, 4, 5 divisions to make up 50 milliampere between 100 and 150. So we have 100, we have 150, and between these two we have 5 divisions. So the total difference between these two is 50 milliamps, and this 50 milliamp will have to divide it into 5 equal parts. So each part will represent 10 milliamps. So least count of milliammeter will be 10 milliamps. And what about the voltmeter? Voltmeter again has readings from 1 to 2. So the difference between 1 volt and 2 volt is just 1 volt. And this 1 volt is being divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 equal divisions. So each division, so at this point, it will represent 0.1 volt, right? Because it is 1 by 10 volt or 0.1 volt. So the least count of this meter is 0.1 volt. Now we'll have to calculate the resistance of the resistor. We know that because they have given us ammeters and they have given us voltages. So we can use Ohm's law. V is equal to IR. voltage given to us is in the meter, we will have to read it out. So 2, 2.1, 2.2, 2.3, 2.4. It is almost at, I think, 2.3 or 2.4. It is not clear right now, but let us take it as say 2.3. So let us say voltage is 2.3 or 2.4. 2.4, I think. So 2.4 volts is equal to I. I we know it to be 200, 210, 20, 30, 40, 50, 250 milliamps. 250 into 10 raised to minus 3 milliamperes into resistance R. So R will be equal to 2.4 volt divided by 0.250. So R will be equal to 2.4 divided by 0.25. 0.25 can be multiplied with 4 to get 1. So we'll just multiply both the numerator and denominator with 4 to get the answer to be 4 4s are 16, 4s are 8 plus 1 9. So 9.6. So it is 9.6 ohms basically. The resistance of the answer of this second sub question will be 9.6 ohms, and the least count of the 2 meters are 10 milliamperes and 0.1 volt. But this question was out of the syllabus. We do not have any least count and all at class 10. Next question, a student Ria, question 31, a student named Ria is conducting an experiment using a coil wound around a long hollow cardboard tube connected to a battery to demonstrate the concept of electromagnetism. Okay, we have a circuit which consists of a solenoid. So this is a solenoid. We have a cardboard roll which has two faces A and B. We have a battery, we have a rheostat, and we have an ammeter. Show the magnetic polarity acquired by each face of the solenoid. So they have given us the direction of current. So when we look at this face A, this wire which is carrying current in downward direction is behind face A. That means it is at this point, right? So if current is flowing in downward direction, that is at face A we have anti-clockwise flow of current, right? So at phase A, we have anti-clockwise flow. When we write, let us write N and S and then see which direction do we get from N and S. From N we get anti-clockwise, right? N we get anti-clockwise and out of S we get clockwise direction. So because the flow of current at phase A is in anti-clockwise direction, that means it must be possessing north polarity. That asked us show the magnetic polarity acquired by each phase. So at A we know it is north pole, then B it will be south pole. There will be opposite poles being formed. Draw the magnetic field lines of force inside the coil and also show their direction. So direction will always be within the bar magnet, it is always from south to north. So we'll just draw this to be A, this to be B, this is north, this is south, and we'll show the parallel magnetic field lines, parallel and equally spaced magnetic field lines with the direction from B, arising out of B and flowing into A. So this will be the answer for B or the second sub question. Third sub question, mention two methods to increase the strength of magnetic field inside this coil. So to increase magnetic field of the electromagnet, there are two things which we can do. We can increase the number of turns or coils of the solenoid. Turns, loops, coils, you can use any word. Or we can increase the amount of current. Increase the current by using rheostat. Decrease resistance. This can be done by decrease resistance of rheostat to increase circuit current. So this was question 31. Next question 32. And the image of a candle flame placed at a distance of 30 centimeter. So candle flame is placed at a distance of 30 centimeter. So U is given to us as minus 30 centimeter from a mirror. So they're talking about a mirror now. Is formed on a screen. So screen is being used. That means the mirror must be concave. only concave mirrors can form real images which can be caught on a screen. So we'll just write down mirror has to be concave because screen is used. So if mirror is concave, that means focal length has to be negative. We should get a negative answer for focal length and radius of curvature. Both must be negative for now. Next, let us continue to read. Screen placed in front of the mirror at a distance of 60 centimeter from its pole. So they have given us the image distance. Image distance is again in front on the real side, which is negative minus 60 centimeter. What is the nature of the mirror? Nature of the mirror is concave and converging. Converging mirror. Its type is concave mirror and its nature is converging mirror. Find its focal length. To find out the focal length, we'll have to use mirror formula 1 by f is equal to 1 by v plus 1 by u, which is equal to 1 upon minus 60 plus of 1 upon minus 30. So this will turn out to be 1 upon minus 60 minus of 1 upon 30, or just minus 1 by 60 minus 1 upon 30, which will be equal to times 2 minus 1 minus 2 upon 60 is equal to minus 3 upon 60. 3 ones, 3 twice, so 20. So this implies f must be equal to minus 20 centimeter. This is the focal length. Next, if the height of the flame is 2.4 centimeter, so they have given us the height of the object. H is 2.4 centimeter. They are asking us h dash. Find the height. This is not h8 of its image, it is height of the image. So h dash will have to be found. So to calculate h dash, we always use magnification. Magnification will have the formula of m is equal to h dash by h, and it also has the formula of minus v upon u. So h dash is unknown. H is known as 2.4 centimeter. Negative of minus v. We know to be minus 60 upon minus u, which is minus 30. So we can cancel out the negative signs first. We can cancel out the zeros. 3 ones, 3 twice. So h dash by 2.4 must be equal to minus 2, or h dash must be equal to minus 2 into 2.4. So h dash is equal to minus 2 4s are 8, 2 2s are 4. So 4.8 centimeter. So we'll just say height of the image is 4.8 centimeter in size, but is inverted. State whether the image formed is erect or inverted. It is inverted because height turned out to be negative. It has a negative sign. Or because screen is being used, that means image is real. If image is real, real images are always inverted. Next, question number 34. An organic compound A on heating with concentrated H2SO4 forms a compound B, which on addition of 1 mole of hydrogen in presence of nickel compound forms C. So let us read one sentence at a time and let us try to jot it down. An organic compound A. So A. Organic compound, they have used the word organic, that means it is from the chapter of carbon compounds. So A on heating with concentrated H2SO4 forms compound B. Done. Which on adding 1 mole of hydrogen, so B plus hydrogen in presence of nickel catalyst forms compound C. 1 mole of compound C on combustion means it has to react with O2. So every time it reacts with, whenever combustion takes place for carbon compounds, it will always be forming carbon dioxide and water. So C2 and H2O. And they've given us how many moles of CO2 is being formed. So 2 moles. So they have given us the coefficient of CO2 to be 2 and 3 moles of H2O. So 3 is the coefficient of H2O. So this means because it has 2 carbon in it, C should have 2 carbons within it, right? So 2 carbons, and how many hydrogens does it have? 3 to the 6 hydrogen. So this C must have the formula of C2H6, and we know that C2H6 is nothing but ethane, because double of 2 would have been 4. So 4 plus 2, 2n plus 2, this formula is being used. So it is ethane. So if C is ethane, so ethane is being formed by adding hydrogen. This must be addition reaction. So addition reaction is always used to break covalent bonds and add hydrogen, right? So how many hydrogens are being added? Just 2 hydrogens are being added. So that means this must be ethene. Ethene will get converted into ethane, right? By addition reaction. One bond out of the double bond will be broken and 2 hydrogens will be added. to form ethane, right? So we come to know that B is ethene. So if B is ethene, so what might be A, substance A. Let us read the first statement again. An organic compound A on heating with concentrated H2SO4 forms compound B, ethene. So it is forming ethene from a organic compound. So this reaction, we know that ethene is formed from ethanoic acid. No, ethanol. It is formed from ethanol. Let us write the molecular formula of ethene. Ethene is C double bond C with two H's on either side, right? What is the molecular formula of ethanol? C H H H C H H and OH, right? So we know H2SO4 is dehydrating agent. So it will dehydrate, it will take away water molecule, and water molecule is taken away from one H from the left and OH from the right. These two will combine to form H2O, and these two bonds on either side will combine to form the second covalent bond between carbon atoms. So we came to know that A is ethanol. So we'll just write down A is ethanol. A, ethanol. B is ethene. C is ethane. And the chemical reaction, first reaction is conversion of CH3, CH2, OH into ethene, CH2 double bond CH2, along with water being released. So dehydrating agent concentrated H2SO4 is being used for the first reaction. The second reaction will be a reaction of conversion of ethene into ethane. So ethene is CH2 double bond CH2. So it will be reacting with hydrogen in presence of nickel catalyst to form CH3, CH3. So this is ethane being formed. So ethane CH3 plus CH3 CH3 will combine with oxygen to form carbon dioxide, and they have already given to us carbon dioxide is 2 plus 3 H2O. To balance it out, we'll need to count the number of oxygens. 3 2s are 6, 2 2s are 4, sorry, 2 2s are 4 oxygen plus 3 1s are 3 oxygen. So totally we have 7 oxygens. So 7 by 2 will be 3.5. So if we have 3.5, we'll have to multiply everything with 2's. So into 2, into 2, into 2. So they have not directly given us the coefficients of this reaction. We'll have to use other coefficients. So when we multiply everything with 2's, we get 2CH3, CH3 plus 7O2 to form 4CO2 plus release 3H2O. So this is the balanced chemical equation for the third sub question. Or question we had a sub question, identify the functional groups in the following molecules. So here we can see it is OOH. OOH will be carboxylic acid. So we'll write carboxylic acid is the functional group with C double bond O and OH as a functional group. And in the second case we have CHO or aldehyde. Aldehyde is a functional group with C double bond O and H as the functional group structure. Write the formula and draw the electron dot structure of cyclopropane. Cyclopropane. Propane. Prop means 3. Ane means single bond, right? So we'll need 3 carbon atoms. So we'll draw 3 circles. 3 overlapping circles of carbon. C, C and C, because it is ane. So the bond between two carbons will always be single bond. So single bond between these two, single bond between these two, and single bond between these two. And lastly, every carbon should have formed 4 covalent bonds. So this carbon has already formed, the first carbon has formed 1 covalent bond and second covalent bond. So 2 covalent bonds have been formed. So it needs 2 more. So we'll need to add 2 more hydrogens to this molecule. So H and H. So we'll need to add 2 hydrogens to each carbon. Next, we'll just write the element name H, 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 H and H. Towards carbon will show X's, towards hydrogen will show dots. So X dot, X dot, X dot, X dot, X dot. So this is cyclopropane. They also want us to write down the molecular formula. Molecular formula will be C3H6, and its structural formula will be C single bond C single bond C single bond back to the first C, and 2 H's with every carbon. So this is the structure of cyclopropane. This is the molecular formula, and this is the electron dot structure of cyclopropane. Next, distinguish experimentally between ethanol and ethanoic acid. So experimentally, we can differentiate between ethanol and ethanoic acid by using the property of base and acid. Bases cannot react with metal carbonates or metal hydrogen carbonates, right? But ethanoic acid can react. So this reaction was already used, had been used somewhere. Metal hydrogen carbonate in the test tube part, that given us 2 test tubes, 4 test tubes. So metal hydrogen carbonate, the same reaction of acetic acid with sodium hydrogen carbonate will produce CO2, while if we use ethanol, it won't be producing the effervescence of CO2. So that part, this question is from the textbook itself, from the carbon chapter. So you can refer to your textbook answers from the notes. Name 2 good oxidizing agents. So in carbon and compounds chapter, we have 2 oxidizing agents. First one is KMnO4, potassium permanganate, and we have K2Cr2O7, potassium dichromate. Potassium dichromate has to be acidic, acidified, and KMnO4 will be alkaline. Alkaline KMnO4 or acidified potassium dichromate are the 2 good oxidizing agents. So write their chemical names and their molecular formula as well. Why does hard water not produce foam with soap easily? This is also from the notes itself. You can refer to it from the either from the textbook or from the notes. State right hand thumb rule, theoretical question. A positively charged alpha particle is projected towards west. Okay, so let us write down the directions first. Alpha particle is projected towards west, so it is being projected towards west. Alpha particle is being projected towards west. So alpha particle is positive in charge, positively charged. So current is flowing. So this is the direction of current. Current is flowing towards west side, west direction. Gets deflected towards north. So the motion is towards north. Motion towards north, current towards west. So by using Fleming's left hand rule, if current is towards west and the direction of deflection, this is west, current is towards west and deflection is towards north, that means the magnetic field must be in upward direction. Magnetic field will be in upward direction. The direction of magnetic field is directed upwards, or out of the paper. Justify 2 magnetic field lines never intersect each other. So by placing the magnetic compass at the point of intersection, it will have to show 2 directions simultaneously, which is never possible. How will the magnetic field be affected on reversing the direction of flow of current in the conductor? If we reverse the direction of flow, the polarity will get reversed. Polarity of magnetic field gets reversed, and magnetic field lines reverse their direction. Increasing the current, magnetic field becomes stronger. So we'll write these 2 sentences. This was from our mock test itself. Next, for the combination of resistors shown in figure, find the equivalent resistance between M and N. So they have not given us the values of R1, R2, R3 and R4. How are we supposed to calculate the effective resistance now? So let us just write down the formula then. They might have announced some value here. So basically, if we start the current to flow from M, the same current will flow through R1 and R2. That means R1 and R2 are in series. So we'll combine R1 and R2. R1, R2 are in series, and then we have R3 and R4 in parallel. So we can combine these two to form a single resistance, RS1, and we can combine these two to form a single resistance, RP1. And now these two are in series connection. So we can combine these two to form RS2 or just RT. This will be RT. So how do we get the formula for RS1? RS1 will be R1 plus R2. RP1 will be the reciprocal of RP1 will be equal to 1 by R3 plus 1 by R4, which is basically R4 plus R3 divided by R3 times R4. So this implies RP1 will be equal to R3 times R4 divided by R3 plus R4. And lastly, RT will be the series of everything, RS1 plus RP1, which is R1 plus R2 plus R3 R4 divided by R3 plus R4. If they have not given you the values in ohms for all the four resistances, then we'll leave it as the answer. This is our final answer. We'll just derive an equation or a formula for the effective resistance. State Joule's law of heating you can refer the textbook. It is basically heat is directly proportional to square of the current, directly proportional to the resistance through which the current flows, and it is directly proportional to the time for which the current flows through the resistance. Sub question C. Why we need 5 ampere fuse for an electric iron which consumes 1 kilowatt power at 220 volts? So we'll not basically read everything. We'll just label all the given values, list the given values. So the given values are I is given to us 5 amperes. Next, kilowatt is given to us. Kilowatt is the unit for power. So power will be 1 kilowatt, or when you convert it to SI units, it will be 1000 watts. And lastly, we have voltage is equal to 220 volt. And they're asking us why we need 5 ampere. That means why the answer is 5 ampere. So how can we use P and V to get I? We have the formula for P and V. P is equal to VI, right? So let us substitute the values and assume that I is unknown. We have to find out I. P will have the value of 1000. So 1000 is equal to 220 into I. So 1000 divided by 220 is equal to I. So when we cancel these two out, we'll get the result to be 100 by 22 or 50 by 11. 50 by 11 is equal to I. So let us divide 50.000 divided by 11. 11 4s 44 minus 6.0, 11 5s 55. So again 5 4s 44, 6 again 5. So we'll be getting the current to be 4.545, right? So this is the current required by the heater, electric iron. So iron needs current of 4.545. So to protect it, we choose fuse which has slightly higher capacity, higher rating, which is 5 ampere. That is why we are using 5 ampere rated fuse, because the iron needs 4.5 ampere of current. If we use a fuse which has a rating of say 4 amperes, then when the current flows, a current of 4 ampere flows through the fuse will melt away. So we cannot use 4 ampere fuse. The current required is 4.5. We can use two fuses, one of 4 ampere or of 5 ampere. So if we use a fuse of 4 ampere, that means because the iron needs 4.5 ampere, it will be drawing 4.5. So when it tries to pull 4.5, the fuse will melt because the current is more than its capacity. If we use 5 ampere, then the current being used is within the capacity of the fuse. But if it exceeds by too much, if we use say for example 10 ampere fuse, then the fuse won't melt. If the fuse doesn't melt, more current will flow through the iron and the iron will get damaged. So we try to use fuse which has a rating closer to the amount of current being drawn by the device, but it should be slightly more to it, more than it. Sub question D, why is it impractical to connect an electric bulb and an electric heater in series? So basically they are asking, we have a bulb and we have a heater. If we connect both of these in series, then what will happen? We know that in series connection, the currents remain the same. So, and we know that bulb requires less current and heater because it has to generate heat. And by Joule's law, we know that heat generated will be square of current. So it will require too much of current. Heater needs to draw too much current, but bulb needs less current. So if we try to supply current which is less, then bulb will be able to operate. Bulb will begin to glow, but the heater won't work because it doesn't get enough electricity. So we will only be able to operate the bulb, but not the heater. And the other case around, if we try to use the heater and if we supply more current through the circuit, then that high current will also flow through the bulb and the bulb will stop working. It will get fused. It will melt away because it cannot withstand that high current. So that is why it is impracticable. If we use less current, then only bulb works, the heater doesn't work. If we use more current, then the heater works, but it fuses the bulb or shorts the bulb, right? So that is why it is impracticable to connect electric bulb in series with electric heater. The hint was they are connecting it in series, and we know which device uses what kind of current. Next question number 37. Mrs. Tomar uses a compound of sodium X to make pakoras crispy. Pakoras are being made crispy. It is a mild, non-corrosive basic salt, also used as an ingredient in antacid. So in antacid, we know we use what as an antacid? We use bases as an antacid. Which base is used? We know baking soda. Baking soda has one of the uses as being used in antacid. So they are talking about baking soda. Compound X, it is produced by using sodium chloride. Yes, then we are confirmed. Sodium chloride is one of the raw materials. We know how baking soda is formed. Baking soda is formed by using sodium chloride solution, sodium chloride plus H2O. Within this solution, we pass two gases, NH3 gas and CO2 gas is passed. And we make baking soda. Identify compound X of sodium. So we have already identified is baking soda. So common name is baking soda, or it will be sodium hydrogen carbonate, right? Carbonate. Give its molecular formula. Molecular formula will be NaHCO3. So we have given the molecular formula, we have given the scientific name, and we have given the common name, baking soda. Next, is pH value of X solution equal to, lower than, or higher than? They have given us that it is basic salt. So its pH value will be slightly higher than 7. It is non-corrosive. If it is closer to 14, then it becomes corrosive. Because it is slightly higher than 7, it is nearer to 7, it is non-corrosive, but it is basic. Write chemical equation to show its preparation from sodium chloride. So they want us to write the equation for this reaction, passing of ammonia and carbon dioxide through a brine solution. So let us write down NaCl plus water. Through this we are passing NH3 gas plus CO2 gas. And one of the products which we are getting is, we know it is sodium hydrogen carbonate. So NaHCO3. So how do we get NaHCO3? I've always asked you to write water as HOH within the reactions, right? So NaHCO3 will be formed by using Na. Na is combining with OH. So it is getting one H and it is combining with CO2. So we are getting one Na, one hydrogen, carbon dioxide, so CO2, and one additional oxygen is being obtained from this OH part. So what else remains? Chlorine remains, H remains, and NH3 remains. So it will be forming, NH3 will combine with H to form NH4 and Cl. So ammonium chloride is being formed. So we'll just write down sodium chloride solution, or sodium chloride with water with ammonia gas plus carbon dioxide gas reacts to form sodium hydrogen carbonate and ammonium chloride. plus ammonium chloride. Even if you don't remember the whole chemical reaction taking place, just remember the statement of the formation. So how is baking soda formed? Baking soda is formed by passing ammonia gas and CO2 gas through brine water. Through brine water, or just remember salt solution. Salt solution. In salt solution, we know salt is NaCl. Solution will be formed by adding it in water, right? Next, they want us to write the reaction when X is heated. So X is NaHCO3. When NaHCO3 gets heated, it will be forming some salt and it will be releasing water vapors and carbon dioxide gas, right? So which salt gets formed? So to find out which salt is being formed, we'll have to look at what changes are taking place. So CO2, to form CO2, we'll need to take away oxygen from carbonate, right? So this oxygen will have to combine with H, but we need two H's. So we'll need two NaHCO3. So Na, NaH, CO2O. So CO3. NaHCO3, first NaHCO3, second NaHCO3. So it is forming H2O and it is releasing carbon dioxide gas. Carbon dioxide gas is being released. So to balance it out, we need two hydrogens. So two hydrogen, two Na. What remains? Na and CO2. This has formed H2O. So 2 Na and CO3 will remain. This carbon dioxide goes away. So Na2CO3 will be formed. Na2CO3 is being formed. Let me repeat it again. This was not clear enough. So let me just use Na has one H and it has carbonate. Carbonate has CO2 and one O, right? But we need to form H2O. We have just one H's. So we'll need another molecule of NaHCO3 and that CO3 will again have CO2 and O, right? So now to form water, we need H2O. So H2 and one of the O's went away. So H2O got formed. H2O. We have formed H2O. So H2O has been obtained. We need carbon dioxide. Carbon dioxide is also obtained. What are we left out with? We are left out with two NAs and CO2 and O. CO2 and O will be CO3. So Na2CO3 is the salt being formed. So sodium carbonate, water vapor, and carbon dioxide gas will be formed. So just write down gas, gas, solid, solid. This is the reaction taking place for the second reaction which they had asked. Or sub question, why is compound X used as an antacid? Because it is basic in nature. Acidity is caused when we have more acid or excess acid present within the stomach. So excess acid will get neutralized by this basic salt to provide relief. Give two more uses of compound X. So uses of compound X means uses of baking soda. Baking soda had three uses. It is used to make used in cakes or used to make baking powder. Baking powder by addition of tartaric acid. Tartaric acid. Next, it is used as an antacid, but they are not asking us to write this. This is already given. And the last use for baking soda was it was used in soda fire extinguisher. Soda acid fire extinguisher. Soda acid fire extinguisher. So in this soda fire acid extinguishers, we use baking soda. And last question, we have a paragraph given to us. We'll have to go through it. The questions being asked are, what is the function of pupil in human eye? So function of pupil, the pupil regulates and controls the amount of light entering the eye. They have given us the answer within the paragraph itself. What is the far point and near point of human eye with normal vision? So far point will be infinite meters, and near point will be 25 centimeters. This is the range of normal vision. A student has difficulty reading a blackboard while sitting in the last row. What could be the defect of the child is suffering from? Why? He is not able to read from the last row, so he is far away from the board. So it is, he is not able to see far objects, he is able to see near objects. So it is nearsightedness or short-sightedness. Near-sighted, short-sighted, or myopia. The defect with a smaller name, shorter name. What is the function of why? They have asked us the causes of myopia. Causes of myopia, one of the cause they had already given to us. This curvature part. A person went for medical checkup and found that curvature of his eye lens was increasing and myopia, right? So myopia increasing. If you get it wrong here, you will be getting wrong in the last question also. So one of the causes is curvature increases. Curvature has increased. Or what else might have happened? Normal eye focuses light onto the retina. For myopia, it gets focused at a shorter point. That means the eyeball has become elongated. So elongation of eyeball. These are the two causes. Next, what is the function of iris in human eye? Have they given that too? Iris behind the cornea. Iris is a dark muscular. This is also given. Iris is a dark muscular diaphragm that controls the size of the pupil. So out of the two questions they have given you, out of the three questions they have given you two answers. Two ready-made answers had been given to you. So 2 free marks. So this completes our physics and chemistry portion, physics and chemistry section of this question paper. So if you have any doubts, then you can ask or you can attend the doubt clearing sessions.